So, hello students. Today we discuss about Lewis theory of acids and bases. So, already we know about Arrhenius theory, which explains the acid in terms of H plus and base in terms of OH minus. And we know the Bronsted-Lowry theory, which explains the acids and bases based on H plus. That was known as Protonic theory. So, it is in the Lewis acid base theory, the basic thing is it is given the definition of acids and bases in terms of electron pair. In terms of electron pair. So according to this theory, what is an acid? So the acid means the chemical species. First I will explain. The chemical species which can accept an electron pair. The chemical species which can accept an electron pair from other compounds, from other species, and forming a coordinate covalent bond with it. Mean just not only taking the electron pair, it should form a coordinate covalent bond with that other species. Then it is treated as an acid. To get an electron pair, it must possess empty orbital. Just sharing of electrons, it's a different thing. But it should accept the electron pair and it must possess empty orbital. Means the chemical species which can accept an electron pair by possessing an empty orbital is called an acid. In the same way, what is the base? Base also in terms of electron pair. The chemical species which donates an electron pair. The chemical species which donate the electron pair to other substance, forming coordinate covalent bond with it. Coordinate covalent bond means nothing but it is also known as dative bond. Okay. Means it should contain lone pair of electrons. Okay. Donate challenge compulsory, it should possess lone pair of electrons. Means simply we can write the definition like this. So acid means the substance which accepts electron pair. It may be one pair or more than one pair also. The substance which accepts electron pair forming coordinate covalent bond with other species are called acids. The substance which can accept electron pair and forming coordinate covalent bond with other species is called acid. Means it must possess empty orbital. So it is a condition. Okay. So in the same way we can define the base. So according to Lewis theory, what is the base? Same, the substance which can donate one electron pair or more than one electron pairs. And same, it is also forming coordinate covalent bond with other species are called bases according to Lewis theory. Next, so what is the condition? It must possess lone pair of electrons. Lone pair of electrons means in the formation of a bond, some atoms having some unshared electrons which are not participated in the bond formation. Just like if you see the NH3, We know that nitrogen forms 3 bonds with the 3 hydrogens, and one lone pair of electron is there on the nitrogen atom. Means NH3 works as a Lewis base. Okay, now we see the examples also. Examples, what are the Lewis acids? Lewis acids ke examples we can write. So all cations. So cations means we know that they are electron deficient. Cations means having positive charge. They are ready to accept the electrons. So we can say they are electrophiles. All electrophiles. Electrophiles means nothing but all cations. All cations means just like Ca plus 2, Na plus, Mg plus 2. So all we can write even ammonium NH4 plus. So all cation works as like that. Next, there is some other examples are also there. So oxygen, sulfur. So they are having lone pair of electrons. Sorry, oxygen, sulfur having a vacant orbital, so they are ready to accept the. Actually, they are having 6 electrons in it in the valency. By getting 2 electrons, they will get octet covered. They are ready to take that electron. These are some general examples. Separately, there is one topic is there to explain the examples of Lewis acids and bases. Just in the theory, we are giving some examples. So bases means which are ready to donate the electron pairs. Ready to donate the electron pairs means they must have lone pairs, or they must have rich in electrons. So we can say all anions. All anions means Cl minus, Br minus, I minus, F minus, O minus, to all anions. Okay. Even those which are having the lone pair of electrons in NH3, nitrogen having a lone pair. So even if you take some amine, some other compounds. So these are the some examples. Actually, in the next class we discuss total about the examples. Okay. So this is about the definitions of acids and bases according to Lewis theory. Next, we know very important thing in every theory is the acid-base reaction. Okay. So what is the neutralization in this reaction? So neutralization. We know that neutralization means the reaction between acid and base is treated as a neutralization reaction. Here in the neutralization means in acid-base reaction what happens? Simply base donates the electron pairs and acid takes that electron pair. Means in acid-base reaction what takes place? The transfer of electron pair from base to acid forming a coordinate covalent bond. So here we can neutralization reactions means in acid-base reaction transfer of electron pair from base to acid takes place. Forming dative bond. Dative means nothing but coordinate covalent bond. Forming dative bond means in acid-base reaction there is a formation of a dative bond between the base and acid takes place. Here base is treated as a donor. In dative bond we know that the shared, actually dative bond is also one of the special case in covalent bond. Sharing of electrons takes place here also. But the shared pair of electrons are provided by only one of the bonded atoms. The shared pair of electrons are provided by only one of the bonded atoms. That is called dative bond. Here totally Lewis base donates the electron pairs, and Lewis acid takes that electron pairs and shares that electron pair, forming a dative bond. So means here we can say the one point. So acid base, according to this theory, it's a very important point. Acid base reaction takes place by the formation of a dative bond. We know that dative bond means coordinate covalent bonds. It is a special case in the covalent bond, and we know that covalent bonds are formed slowly. Means therefore we can say it is a slow reaction. Indirectly we can say the formation of dative bond is nothing but actually the dative bond formation is slow. That's why acid base reaction is also according to Lewis theory. It is also a slow reaction. Okay, now we see some examples of acid base reactions. See the reaction between NH3 and H+. So in NH3, nitrogen has a lone pair of electron. H+, we know the nitrogen structure is like this. Nitrogen having how many valence electrons? 5 valence electrons. If in that 5 valence electrons, 3 electrons are used in the bond formation with the 3 hydrogen, and one lone pair is present on the nitrogen. Let's see, if you see the hydrogen, normal hydrogen 1s1. So what is the H+? H+ means it becomes 1s0. Because the formation of H+ and the losing of one electron, so it becomes 1s0, means 1s orbital is vacant. So there is a perfect possibility of ammonia to donate the electron pair, and H+ possesses a vacant orbital. There is a transfer of electron pair from NH3 to H+ takes place. So here NH3 donates the electron pair. So NH3 treated as a Lewis base. At NH3, which part given the electrons means nitrogen giving the electron. You have to remember that case also. Which atom is giving electron pair in the ammonia? Nitrogen giving the electron pair. Okay. So now the product we can write like this. So NH3, you can write NH3, H3 and whatever. Here nitrogen donated kabatti I am writing the nitrogen at this side. Nitrogen donates the electron pair to H+. So generally it is commonly written as NH4+. So actually the positive charge, so after the bond formation, the positive charge not only present on the one H+, it totally nothing but the positive charge shifts from one hydrogen to other hydrogens also. Means the positive charge transferred to one hydrogen to other hydrogen after the formation of a dative bond between NH3 and H+. So that's why we can write as NH4+ ammonium. Now check what is the acid, what is the base in this reaction. So NH3 donated the electron pair. So here we can say NH3 is a, according to Lewis theory, it is a base. So what is the H+? H+ accepted the electron pair, so it is a Lewis acid. So how we are saying it is a Lewis base means as it donates electron pair. So why H+ is treated as a Lewis base, Lewis acid, as it accepts an electron pair and forming a dative bond between them. Okay, next see one more example. The reaction between water and H+. So obviously we know in the NH2 molecule there is two lone pairs are present on the oxygen. Two lone pairs are present on the oxygen. If you know the structure of H2O, so it is like this. is having 2 lone pair of electrons. Actually, oxygen belongs to 16th group. It is having 6 valency electrons. In the 6 valence electron, the 2 electrons are used in the bond formation with the 2 hydrogens. The remaining 4 electrons are left present as lone pairs on oxygen. And we know that H plus means there is 1s0. 1s0 means it is having a empty orbitals. And there is a transfer of 1 electron pair takes place. Even H2 is having a 2 lone pairs on the oxygen atom. It donates only 1 electron pair. So, and there is a formation of H2 to H plus. There is a formation of a dative bond takes place between it. So, it can be written as hydronium ion. It is known as hydronium. Same here also, the positive charge not only exists under this H plus, it transfers on the all hydrogens. That's why commonly we can write H3O plus. So here see, what is the H2? That's I'm writing the here. So what is H2? H2 is a Lewis base. Again I am writing the points. Here H2 in this reaction, H2 is a Lewis base because I donates an electron pair to it. So what about H plus? Say in this reaction also H plus is works as a Lewis acid as it accepts electron pair. Okay, see one more example. So again NH3 plus BF3, boron trifluoride. Okay, so we know that nitrogen is having a lone pair of electrons. In NH3, nitrogen having lone pair of electrons. In the BF3, okay, in the BF3, boron having a vacant orbital, a vacant p orbital, and there is a transfer of the nitrogen donates that electron pair to that boron and forming, that is NH3. We can write NH3 or H3n. Nitrogen donating, that's why I am writing in this form. Nitrogen donates an electron pair to the BF3. In BF3, which atom accepts the electron pair and the boron? Generally, central atoms are involving the donating the electron pairs and accepting electron pairs. So there is a formation of a dative bond here. Next, we can write here NH3 works as a Lewis base. We have to write the sentences separately. NH3 is a Lewis base as it donates an electron pair. Let's see what is boron trifluoride. Boron trifluoride a Lewis acid because it accepts an electron pair. So what is the importance of this example is actually here NH3 lo manaki there is no doubt. In the Bronsted theory also it was treated as a base because it accepts the H plus. In this theory also, according to this theory also, it donates the H plus kabatti. It also treated as a base. But the thing is BF3. The BF3 was especially we discussed about the BF3, AlCl3, B2H6 and BCl3, which are known as electron deficient compounds. In the electron deficient compounds, generally they works as acidic nature. Generally their nature is acidic nature. But how they are acting as acid, it is not at all can be explained with the help of Bronsted theory. So actually it was a big drawback in Bronsted theory that Bronsted-Lowry theory does not explain the acidic nature of electron deficient molecules because that was in terms of total H plus. But here with the help of Lewis theory we are able to explain the acidic nature of electron deficient compounds like BF3, BCl3, etc. because it is in terms of electron pairs. So already we said they are electron deficient compounds. Lewis theory is in terms of electron pair acceptance treated as acid. So as they are electron deficient, they are ready to accept the electron pairs and they are treated as an Lewis acid. Okay. So next we can write some more examples. So here one more very important one. So it's a metal ion. Cl minus, and so there is a formation of FeCN6 minus 4. So here what is this compound? We know that the square bracket compounds are generally known as complex compounds. Generally they are formed by transition metals. In very rare cases sodium also forms a complex compounds, but the maximum 99.9% of the complex compounds are formed by transition metals. You know, iron is a transition metal. They form complex compounds. We discussed it in the special properties of D block elements. Okay, so here see Fe plus 2. Actually Fe plus 2 having many number of vacant orbitals. In the Cn minus, here carbon is able to donate an electron pair. Nitrogen is also ready to donate an electron pair. So what is the specialty of Cn minus? Again here, carbon can donate an electron pair, nitrogen can donate an electron pair. But the thing is, in the reaction only donation of electrons by one atom will take place. Okay, so either carbon donates electron pair or nitrogen donates electron pair, but total cyanide species donates an electron pair. So here 6 cyanides are there. 6 cyanide donates totally 6 electron pairs to the Fe plus 2. Okay, this is known as complex compound. Okay, in the form of, it is given in terms of ion. So means here Fe plus 2. Fe plus 2 is a Lewis acid or base. It accepted the electron pairs. Actually, it accepted 6 electron pairs individually donated by 6 cyanides. So, it's the Lewis acid as it accepts 6 pair of electrons. Next, Cn minus is a Lewis base as it donates 1 electron pair. So not only in this compound, not only in this complex compound, in any complex compound, the central ion is metal ion. Central ion is always accepts the electron pairs from other compounds. What are the other compounds? Other compounds are known as ligands. If iron is a metal ion, Cn minus is treated as a ligand. Means that this ligands always donate the electron pairs, means they works as a basis. The central metal atom always takes electron pairs. That's why in a complex compound we can write a clear sentence that always in a complex compound, metal ions works as Lewis acids always, and ligands. Ligands means which donates metal to part complex lo unna other ions manam ligands antam. I don't think that ligands are always negative. They may be positive, they may be negative, they may be neutral, but they are ready to donate at least 1 electron pair. Some donates more than 1 electron pairs also. Ligands are Lewis bases. So if you see this Fe plus 2, it's a given compound, Fe plus 2 Cn minus. So actually the complex portion is like this. Cn minus, the central metal ion, all cyanides each provides 1 electron pair. So the total charge, this is minus 6 plus 2 is treated as a minus 4. This is called the central metal ion in the complex compounds, always taking the electrons, means works as the Lewis acids. Next, the side atoms, means which donates electron pair to the metal ion in the complex, always minimum donates one electron pair. Some ions, some ligands are there ready to donate the 2, 3, 4, 5, 6 pair of electrons also they can donate. But generally 1 or 2 are maximum examples. So we know that they donate one electron pair or more electron pairs, they treat it as a Lewis basis. It means in a complex compound, ligands are Lewis bases, central metal ion is a Lewis acid. So next, here very important thing is strength. Strength of acids and bases. Here very important thing is, so already I'm comparing this theory with Arrhenius and Bronsted theory. In Arrhenius theory, there is a thing is introduced that is called dissociation, degree of dissociation of acid, that's called dissociation constant, acid dissociation constant, degree of dissociation of base or base dissociation constant. And more dissociation unte, they works as the strong acids and strong bases. If less dissociation is there, they called weak acids and weak bases. That's the Arrhenius theory. Next, in the Bronsted theory, Bronsted-Lowry theory, if it is ready to release more number of H plus and strong acid, if it is ready to accept the more H plus and that is a strong base. If it releases less number of H plus, that is a weak acid. If it is ready to accept the less number of H plus, that is a weak base. And strength, some కొన్ని acids strong ఉంటాయి, weak ఉంటాయి, కొన్ని bases కూడా strong ఉంటాయి, weak ఉంటాయి. How it is possible, why it is happening like that అంటే, with the help of Arrhenius theory it was already explained, with Bronsted theory also it was explained, but in the Lewis theory it was not explained. According to this theory, all acids are same type, all bases are same type, and there is he not given any points for the explanation of strength of acids and bases. కొన్ని acids strong ఉంటాయి, weak ఉంటాయి, why it is. కొన్ని bases strong ఉంటాయి, weak ఉంటాయి, why it is, means there is no explanation for the strength of acids and bases. Okay. Next, so what are the drawbacks? What are the limitations? What are the failures of this theory? Means main, just now we discussed. The main drawback is it does not explains the strength of acids and bases. So next, one more important, so generally acid base reactions, generally just leave any theory, Arrhenius, Lewis, Bronsted, just leave all the theories. Just if you see the acid base reaction experimentally, acid base reactions experimentally are known as or observed as instantaneous reactions. Instantaneous reaction means they are very fast reactions, and actually they are based on their speed than the rate of reaction. Speed basis there is a mainly different types of reactions are there. Very fast reactions, slow reactions, next moderate reactions, and very slow reactions. Actually the acid base reactions experimental observed thing is they comes under very fast reactions. But if you follow Lewis acid base theory, acid base reaction involving the formation of dative bond, which is a slow reaction, but experimentally it is observed that acid base reactions are very fast. Means it does not explains the instantaneous reaction of acid and base. Actually, if you follow this theory, it is a slow reaction, but naturally it is a acid-base reaction. It is a instantaneous, nothing but it is a very fast reaction. It does not explain the instantaneous reaction of acid and base. So next, one more important we know many acids which are not, we know the HCl, H2SO4, HNO3, many strong acids are there. Next, we know many bases like sodium hydroxide, potassium hydroxide, many strong bases, we know that. With the help of experiments, we can observe they are acids and they are bases. But if you follow this theory, they are not explained well with the help of this dative bond theory, because they are not ready to formation of a dative bond. Okay, normal get treat chesi acids, bases just like HCl, H2SO4, sodium hydroxide, potassium hydroxide. The main acids bases unnayi kada. The bases and acid, they are not ready to form the dative bond. Means if you follow this theory, they are not treated as a perfect acids. Okay, means it does not explain many acids. Explains many acids, bases, as they are not involving in the formation of dative bond. Okay, so these are the main drawbacks in Lewis acid-base theory. So what are the best things in Lewis acid-base theory? Means the drawbacks in the Bronsted theory was covered in this theory. The main thing is in the Bronsted theory, it was not explained about the electron acidic nature of electron deficient compound, but this theory well explains about the acidic nature of electron deficient compounds. Next, it works as not only in the aqueous medium, it is applicable in aqueous medium and also non-aqueous medium. Even Bronsted-Lowry theory also applicable in aqueous medium and non-aqueous medium, whereas Arrhenius theory is works only aqueous medium. Means there is a some merits are there, some drawbacks are also there. Next, one more thing in the drawbacks we can write it explains the acids and bases only in the presence of acceptors and donors. The same drawback was in the Bronsted theory. So Bronsted theory lo donor of H plus acid, అయితే అక్కడ యాక్సెప్ట్ చేయడానికి some other species should be there. Here also electron pair accept చేస్తే that is acid, but there must be other species should donate the electron pairs. అంటే ఒక స్పీసీస్ యాసిడ్ అవ్వాలంటే అకార్డింగ్ టు దిస్ థియరీ ఇట్ మస్ట్ డొనేట్ ది ఎలక్ట్రాన్ పేర్స్. ఎలక్ట్రాన్ పేర్ డొనేట్ చేయాలంటే acid means it must accept the electron pair. Accept the electron pair అన్నప్పుడు other compounds should be there to donate the electron pairs. Means it also explains the acids and bases only in the presence of other compounds which can donate the electron pairs and accept the electron pairs. Next, it does not tell us about the strength of acids and bases. Okay, next one more example is there. One more good thing in this theory is it covers the many examples. It covers the 90% of acids and bases. And with the help of these definitions, we are able to explain the acidic nature and basic nature of many acids and bases present in the nature. Only 10% of compounds cannot be explained with this theory. Okay, just like Bronsted-Lowry theory. Okay, so there is in the example, there is many number of examples are there. We explain it in the next class separately. Okay.